All right. So on this part, we're looking at the areas of irregular shapes, so we're not really concerned about the perimeter anymore. But that's the objective for this portion of this lesson is, can we find the area of irregular looking shapes like this? Ah, yeah, as a joke, we could have put a picture of someone up here and said, oh, find the irregular shape area. But we're not going to do that. All right, the following shapes have been drawn on squared dot paper. The distance between each dot represents 1 unit. Use what you've learned about area to find the area of each shape. We're going to do this a little bit out of order because it's A through L, but we're just looking at A, F, and J. All right, so this method is used often for 7th graders. 8th graders look at this a little bit different, and that's okay. So here's what most people did, at least in that first class, is they divided it up into squares, and then we count the squares, all right? So we start with this one, 1. The next one would be 2. No, I'm serious. Here we go. 3.
4.
After 3,
5.
Bam, 5. Yes, I knew it. Next up,
4.
6. Oh, yeah.
Next up,
How about
7.
8.
4?
I'm good at this. And then it's 12, I think.
Yeah. What's the next one?
8.
7. All right, there are 14 squares up in count. So the area of A is 14 square units. Bam. So let's go and take that suggestion. I'm going to cut it off right here, this triangle, and I'm going to flip it over and put it right here. So now it is up in here. And then I'm going to cut this triangle off and put it right here. And now what I have is an extremely large rectangle, which we like. We like to find the area of rectangles right here.
Actually, it's better
Right?
than a triangle.
Because I took off these parts right here, right? So the dimensions of these, it looks like 1, 2, 3, 4, 5, 6. It's a 6 by 2 rectangle, so the area is 12 square units. All right, letter J. This is a good one. There's several ways we can go about it. These is we could cut it off right here and say that we have 2 trapezoids and a rectangle, but most people don't like that. So here's what I'm going to do is well, you guys just don't like trapezoids, whatever. I'm going to take this triangle and I'm going to flip it and move it right here. Then I can just ignore all this garbage, right? And I've got that rectangle now. I can do the same thing down the right here and take this rectangle and move it right here, which will give me another different rectangle. So I don't need this garbage right here. I'm using the wrong color. Let's get rid of that garbage. All right, so I've changed the shape, but now I can easily find the area of each of these. I can even start to cut it up and then count the squares. What do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 square units. Bam. All right, looking at B, if we want the area of these. So you could divide this up and just count all the squares. What I'm going to do is just split this up into 2 different rectangles. And this one is a 2 by 1, 2, 3, 4, 5. This one is a 2 by 1, 2, 3, 4. So the area of these would be 8 square units. And the area of these would be 10. So the area of the entire thing would mean I would take 8, add my 10, and I would get the area of the whole thing, 18 square units. Alright, so we want the area of these. And we could cut this up into squares each. There's 1 square, 2 squares, 3, 4 squares. But then this one is half. That's been cut in half, that square right there. Right? So as it turns out, it would be 4 1/2, but no mixed numbers. So I'm going to make it 4.5 units. But since it's area, it is squared. Alright, so this shape, this one we can split it up into a rectangle. A 2 by 1, 2, 3, 4, 5 rectangle. So this has an area of 10 square units. But we've got to figure out the area of this half circle as well. So what's the radius of that half circle? 1. The diameter would be 2, right? So it has a radius of 1. So if I wanted the area of it, I would do 1 times 1 times a pi, but I need to divide this by 2. Excellent work. If we have this other one, then we have a full circle, which means we can just make that 1 times 1 times pi, right? Alright, so if we multiply these and then round it, I would get 3.14 units squared. But I need to add that to 10, right? So my total area would be 13.14 units squared. Alright, the first thing I'm going to do is cut this up into shapes I'm familiar with, like 2 triangles. But this one's hard to work with, so I'm going to change it into 4 triangles. What? Yeah, that's what I just did. So what I can do is I'm going to take this triangle right here, and I am going to move it down right here. Now I'm going to ignore all that garbage right there, okay, because I got rid of it. Next, what I can do is I'm going to take this triangle right here, and I'm going to move it right here. Now what I have is an extremely large rectangle right here. And this has been cut up now into 3 squares. So the area is 3 units squared. Alright, H, we're going to cut this up into 2 objects. Right here. Now what I have is a rectangle. 1, 2, 3, 4, 5. 5 units by 4. So the area of the rectangle is 20, which we will put over here. Then I have this half circle right here, and the center is right up in here. So it has a radius of 2. So if I want the area of that half circle, I would take the radius 2 times the radius 2 times a pi. But I'm going to need to divide that by 2 because it's only a half circle. So, in my calculator, I got 2 times 2 times pi divided by 2. Alright, in my calculator, I got 6.28, which I'm going to need to add these two together to find the full area. 26.28 units squared. Alright, we must find the area of these. Alright, so these, we're going to do the same way as we did those other ones. I'm going to cut this triangle into 2 smaller triangles, and I'm going to move this one right here. Actually, I'm going to move it right here because it makes more sense. Then I'm going to move this one right here. Okay, so now those 2 are gone. And then what I'm going to do is I'm going to take that other one and cut it up right here into 2. So I'm going to take this piece and move it right here. And then I'm going to take this piece and move it right here. And yes, some of you guys noticed that changes this into a rectangle. Let's get rid of those ones I moved. Now, what we have is a large rectangle up in here. And this one specifically is a 1, 2, 3, 4, 5, 6 by 2 rectangle. So the area is 12 square units.
Whoa!
All right, we're going to take this shape right here and move it right here. That will make also a perfect rectangle for us. So I'm going to get rid of this garbage,
I know what the
right?
answer is.
So who can tell us the answer?
8 units squared.
That is correct. This is a 4 by 2. So the area are 8 square units.
Oh my goodness, I feel so smart.
We're going to do L very differently, actually. So I would pay attention to this so you don't miss out on what the heck to do. On this one, what I'm going to do is I'm going to box up the shape in this box. The reason that is because it's going to be hard to figure out how to split this one up exactly, perhaps. So, start again. I got a 3 by 3 square. That's better, right? Now, the area of that square then is 9er, but we have this triangle, D's, D's, and a D's, all of which we need to subtract from the 9er. So if we figure out the area of 1, we can just subtract it from 4 of them. So the area of each is, this is a 2 by 1, 2 times 1 divided by 2. So we're going to subtract it 4 times. So that would give us 5 units squared.
Okay.
Use your knowledge of area and the problems that you've completed above to find the area of the regular, irregular shapes. All right. Well, I'm going to cut this up into 2 separate rectangles. That's 4.5. All right, now we got to find some of these other lengths. So the 7.9 has been cut up because this is 4.5. So the other length would be 7.9 minus the 4.5. So that would be 3.4. So this length is 3.4 right here. We will need that value to find the area of this big one right here, which would be 3.4 times 7.9er. So that gives us 26.86 units squared. Now we got to find the dimensions of this other one. So this length is 3. So to figure out this length, we're going to do 7.9 minus the 3. So this length is 4.9er. So the area is 4.5 times 4.9er, which gives us a new area, 22.05. So if we take these 26.86 and add the 22.05, then we get the actual area of the whole thing, 1948.91 units squared. So this arrow I'm going to split up into a rectangle and a triangle. This length, by the way, is 23.7, which we will need. So the area of the rectangle is going to be 23.7 times 32.4, which is, so we got 767.88 on that rectangle, but we need the height of this triangle right here, and then also the base value, in order to find the area of the triangle. And whatever that is, we're going to divide it by 2. All right, so the height, we can see that this length right here is 32.4.
17.4.
So, yeah, so you did the 49.8 minus 32.4. Yeah, and that's the height, 17.4. So we'll plug that in, 17.4. And we are going to multiply this by the width, which is 9.3 plus 23.7 and plus 9.3. So the base of this is 42.3. And we're going to multiply that, 42.3. 42.3 times 17.4 divided by 2, and that will be the area of the triangle. But we want the area of the whole thing, so we got to take both areas, 767.88 and the 368.01, and we want to add these two together to find the actual area. So what do we get out of that? 1,135.89, and this one we know the units, meters squared. That is it. Alright, this one looks a lot more difficult than you guys think it is actually. But here's what I'm going to do is I'm going to cut this thing off right here. And see this triangle right here? It's going to fit exactly right here to make a rectangle. So yeah, I moved that over, so I don't need to worry about that part. What I have now is just a straight rectangle, which is extremely nice. And this is 30 centimeters by, this is 40, and that's 40, so a total of 80 centimeters. So if I wanted the area of this thing, I would do 80 times 30 in my calculator to get an area of 2,400. What's the units on this?
Centimeters.
Close.
Squared.
Centimeters squared. Very good. Johanna, or Johanna, I don't know. Is that right? Okay, I'll take it. Is building a deck off the back of her house. To the right is a sketch of it. She will need to have a full concrete foundation below the deck. Find the surface area of the concrete foundation. Okay, that's pretty good. Let us do it. But this one I'm going to do a little different than what you guys may prefer. And that's okay. You can do your own way. So we've seen this method already where I just make this a full rectangle, right here. And then I just subtract off this area from that big one. So that would have given us a 15 by 8 rectangle. And 15 times 8. But then I've got this rectangle, which is a 9 by 2. So the area is 9 times 2, which is 18. So I can subtract that off of 120, and that would give me 102 feet squared of concrete. Now suppose that person wants to build her deck onto a concrete foundation that is 1.5 foot thick and has the same surface area as the deck. How much cubic feet of concrete will she need? Well, if this is the surface area, 102 feet squared, the depth is all we need to multiply it by to find how much volume of concrete we will need. Now the answer is 153, but we got to be careful with the units because this is in feet.
It's cubed, so it's
Because it's volume, it is feet cubed because it's 3 dimensions. How many cubic yards will she need?
1 cube divided by
Well, that's 153. A cubic yard would be 9 feet cubed. And that would tell us how many cubic yards we will need. 17 cubic yard of concrete. That is how much cubic yards they would need. Hugo is making a tile pattern shown. The tile is a square, which is nice because since it shows 12 inches right there, then this is also 12 inch right here. He will paint the circles a horrible color and the remaining part of the tile yeller, which is nice. Find the area of the portion of the tile that will be yeller. Alright, so let's identify where those yeller parts will be first. So the circles are not yeller. That means this is yeller right here. This one is yeller. This one is old yeller. This is yeller. Now these are very strange shapes which we haven't dealt with yet. Which is why we're not going to find the area of each of these individually, then add them. What we need is to find the area of the square and then subtract the area of the circles, all 4 of them. That will tell us how much area is left to be painted old yeller. So, to find the area of the square, we do 12 times 12, right? Which is 144 inches squared. So, looking at the circles though, what is the radius of one of these circles? Well, we can see it's been cut in half. So this is 6, it has a diameter of 6 inches. So the radius must be half of that, 3 inches. So the area of the circle is going to be 3 inches times 3 inches times a pi. And what is that when we look at the calculator? 28.27, we'll round that to 28.3 inches squared. Now how many of these do we have though?
4.
We got 4 of them. So we need to multiply this by 4 before we do the addition. So we got 144, 28.3 times 4, 113.2. Oh, I'm sorry, we're not adding these, we're subtracting them. We're subtracting the circles. And that will tell us how much is yeller. So that's a 0.8 right here. That'd be 0 now. 30.8 inches squared. That is how much would be painted old yeller. Alright, so if that much is painted old yeller, we need to find the area of the diamond shaped piece in the middle up in here. So here's what we're going to do is we're going to divide this whole thing up into 4 like these. We can see that each of these 4 is the same as one of these other 4 parts as well. So what that means is if we, I guess we could count how many parts. Let's go ahead and just divide the 30.8 by 4, and that would give us 1, 2, 3, 4 parts. That's all we need. So I've got 30.8 divided by 4, because we had 4 parts here as well, you guys. And that would give us, so 7.7 inches squared for part B. What portion of the tile will be yeller? Well, all of the tile would be 44 rather. And 30.8 of it will be yeller. So we're going to do 30.8 and divide by 144. And that will give us the decimal value. So I got 0.2138 repeating, which converts into 21.38%. Decimal right there. And there is the percentage of the tile that will be old yeller.